Extreme Physics Deep Dive.
Welcome to our first Extreme Physics Deep Dives. We're going to spend some time studying Newton's laws, conservation of energy, rotation, and go deep into error analysis in this Atwoods machine labish activity. This is going to take the better part of a week, and this video is just the first step. There will be additional parts to this activity. As you can see here, I'm setting up one of three cameras, and this is where the mass lands. And I want you to figure out what I was doing there. All right, so as you can see, I have cloned myself using one of those kits from Amazon. Then I removed my head and shrunk it and placed it on one of two 100-gram masses. And your job is to determine the mass of my shrunken head by analyzing this Atwoods machine. Now what I did was I videotaped it with timecode, and I burned in the timecode, as you can see, and now I'm replaying it frame by frame so you can see, so you can get a better measurement, because I know it happens quickly, and I know that most of you don't have easy access to going frame by frame with the video. So here you should be able to get a pretty good time. And keep an eye on the time code. Remember, that isn't that's not just time. That's time code. It's measuring time, but it doesn't measure fractions of a second. It measures minutes, hours, minutes, seconds, and frames, film frames. So you got to figure out, actually video frames. You have to figure out how many frames per second is in this particular video, and you can tell by looking at the time. I want you to pay close attention to the techniques that were used in getting these measurements. Were they good techniques, bad techniques? What was good, what was bad? And if there is ambiguity in any sort of measurement, you need to document it. And we're going to look into how you really need to quantify your errors. You can't just say there's an error. You got to say, how much error is it? Is it significant? And you got to do calculations to determine whether it's significant or not. A little bit later afterwards, we're going to have a better view of the top of the Atwoods machine, where the mass starts. From this particular angle, you really don't have a good view of it, but there will be a better angle coming up soon. So keep in mind, in this first portion of this lavish activity, you're to determine the unknown mass, the mass of the shrunken head. And I'm going to want you to do it two ways. I'm going to want you to do it with a standard analysis using Newton's laws. That's usually how we analyze an Atwoods machine. But I also want you to do it using a conservation of energy. Why don't you check your answer using conservation of energy for this? It's not a standard approach, but it would be good practice to use energy to to solve this and see how could you use conservation of energy to solve this problem, to determine the mass. Right and left as seen by the cameras.
Left mass.
So here I have the 3 cameras going, and here I'm getting a measurement of the placement of the upper mass right before release. And you could see the lower masses. The reason I had that video of that is so you could see that the lower mass was firmly anchored to the landing deck. And here we're getting the position. Note the units on the length measuring device I'm using. It's what I had around the house. I wasn't at school. Didn't have meter sticks. So good luck. Find the mass of the shrunken head using Newton's laws, and why don't you also do it using conservation of energy? Good luck. See ya.
Extreme Physics Deep Dive.